Welcome back to the Renaissance Builder live stream. As always, in the past bunch of videos, we are coming to you live from a cell phone because, that's what we got, so that's what we're doing. All right, so let's start with a drink. And what are we going to open it up with this time? We'll use a flathead screwdriver. How about that? Hi, everybody. I hope everybody's having a good night tonight. Today has been a interesting day, to say the least. I say that as nobody's watching. Anyways, so, my day has been interesting, for sure. I hope y'all's day has been good. Now, the whole point of tonight's live stream is I want to show off what we've actually accomplished. I'm actually pretty excited about this. I genuinely am. I have been working on this for the past 3 or 4 days, and to me, this is a much bigger accomplishment than it may be to some people. Some people may be more used to programming and all that kind of stuff, so this may not be as big a deal to them, but I am not. I am not joking when I say I have zero programming experience. I mean, like a couple Arduino projects here and there, but I'm not a programmer at all. So, this was a pretty big accomplishment for me, and I'd like to talk about it, show you guys what we're doing, and I think what I'm going to do with this project is I am going to make a notebook kind of thing, and all the code and everything that was created. I'm going to make this notebook and I'm going to put it on the Patreon. I think that's what I'm going to do, because this project was a success, and I think other people may be able to use this. Without further ado, cheers to everybody tonight. Let's get to talking about what we did. All right, so camera's at a different angle because I want to be able to show off what we're talking about. Now, so pardon the camera shake, but here's what we got. So, this here gadget right there, this is what you call a Raspberry Pi 5, right? It's the latest edition Raspberry Pi, and it's a very solid piece. I'm actually really impressed with this thing. So, let me show you what I have hooked up. Over on this side, we have the 25 watt power supply into the USB-C. Here we have the HDMI mini to HDMI output, or Ethernet connection. A HDMI, this is an Elgato. Alright, so the camera I have plugged into this thing is an Elgato Facecam Pro. That is a 4K, 60 frames per second USB camera. It's a pretty solid device. So that's what we have plugged into this port, and then over here we have our keyboard and mouse. So that's what's plugged into it. Now, the whole point of this project was to be able to stream a USB camera into an HDMI capture card, specifically for the point of streaming to a Blackmagic ATEM Mini. Basically, I want to move all my live stream hardware over to the ATEM Mini so that can take care of all the live stream equipment. That's the point of this. So, the point... now I'm repeating myself. I apologize. And this took a little bit, so let me power this device up and show you. One of the new things that they have on the Raspberry Pi is I'll show you, is a power button right on the side. So I'm going to power this thing up. The power button can be a little hard to push. There we go. Alright, so you saw the light turn green. And this thing should boot up. We got fan spin. Alright. We got a Raspberry Pi OS environment that boots up. Now, it's not the fastest, okay, but alright, that's the desktop environment, and then boom, that is the camera stream. See? That's my hand. let me show you on the other side. This is the camera right here that we're filming with on the bench top. So this works. Yeah, that's what we got going on here. Now, you might ask yourself, why is this so significant? One of two things is going to go through your mind. Either you know more than I do, which is quite possible, and you're going, well, that's not all that significant. At which point I'm going to go, you know more than I do, so it's more significant to me. Anyways. Or you know about the same as I do, and you go, oh, that is interesting. All right? So there's multiple reasons this is interesting. For one, the Elgato Facecam Pro needs at least 5 gigabytes per second. The Raspberry Pi 5 is the most recent edition of the Raspberry Pi, and they advertise USB 3 5 gigabytes per second. Now, the Raspberry Pi 4 does advertise USB 3, but they don't tell you how fast it is. So I have found inconsistencies in USB communication. Not everybody is actually holding to the USB standard. A lot of cables. You really have to be careful with your cables because a lot of them will advertise that they're USB 3. They'll even be blue with the, the USB 3 moniker, but they won't. They will not have the data transmission. So what I'm trying to say is the 4 may work, the Pi 4. The Pi 5 definitely works. 5 gigabytes per second, we're solid. The camera is putting out a fairly decent image. I know that, you're seeing a camera on top of a camera, so that's kind of odd. And it is a little glitchy. It's not the smoothest image I've ever seen. So that may have to do with the speed of the GPU. It may have to do with the limited RAM. It's only 8 gigabytes of RAM. So it is not the smoothest I've ever seen, but it certainly does get the job done. Now, that's the first thing. USB 3.0, 5 gigabytes per second, and the Raspberry Pi does support the power draw of the camera natively. So that right there takes your device requirements down quite a lot. I have it right here. I did have a piece. This is an adapter called a hat that would give the Raspberry Pi 3.2, USB 3.2. But it turns out that's not needed, and I'm glad because I have 2 more HDMI cameras that are also going to need, I erred. I have 2 more USB cameras. They are the standard Elgato Facecam, so they're only 1080 by 60 frames. But that's still, decent, and they still require USB 3.0. I am going to stick with the Raspberry Pi 5 because the processor is faster. And, hey, Z-Man Edits. How you doing, bud? So I am going to stick with the Raspberry Pi 5 because I believe some of the stuttering in the imagery has to do with the speed of the processor, and I don't want to sacrifice that any more than we already have. Let me show you some of the code that I have that we had to create, and more interestingly enough, I'd like to show you how me, as a tech dumbass, managed to create the code, or I'm going to say managed to acquire the code to make this work. Again, this is something I think I'm going to create as a project with notes and snippets and everything on the Patreon page so that, if you want to do something like that, then you can get access to that project. But what I should be able to do, and I'm going to hold the camera so that you guys can see this, is I should be able to hit Q, and we go to desktop. All right? So now once we're on desktop, and again, I know this is wanky. Sorry. I can't do screen capture yet because I'm having to do, live stream through the phone because, computer's busted. So please bear with me. I know this isn't ideal. So, I got to turn my mouse on. That would be helpful. All right. Let me show you how I've accomplished this. So first, what I'm going to do is I'm going to go up here to Files, right? And in Files, I have this one right here, Camera Stream Dat Log. Oh no, wait, that's not the one. That's my error file. This one, Camera Stream, Camera to HDMI button. I had a button on there. I decided not to go with the button. So I'm just going to click on this, and this is the library code. And I'm perfectly fine sharing this publicly, because once you see how I created or acquired, once you see how I acquired this, you're going to realize that this isn't some kind of private, super special information. Anybody can accomplish this, honestly. So here's the code that actually runs the script. And basically what we're doing is the code engages the driver for the USB. Then it uses software through OpenCV. Is it OpenCV? I think it's OpenCV. And basically that tells the computer how to interpret the image coming across the USB. Then it transfers that image into something that's standard for HDMI process. So we have a transfer going from USB to HDMI, and then it's streaming it to the HDMI output. Now the way the script is written is it engages automatically, and then the Q button is something to be able to disengage it in case you need to change something. The idea of what this is doing is it's standalone. All you would ever have to do to make this work is plug in power, plug in your HDMI, and plug in your camera and turn it on, and it'll start streaming. That's the idea here. Again, I'm going to put all of this on the, I'm going to share it on the Patreon channel, and that way you can see. Now, all right, here's one of my limitations. There's another folder that I need to get to, and I have no idea how to get to it from the desktop. So I'm going to step away from the folders a little bit and show you how I actually created all this. Again, tech dumbass. I barely know how to code in C#. Python definitely was not happening. So what I'm going to do, and this I found really impressive, okay? If you guys are wondering if the Raspberry Pi 5 is worth anything, it is. I may not be the highest resource or opinion to go by, but I was impressed. So I'm going to go up here to, up in this corner. Oh, I'm in the wrong bloody corner. All right, up in this corner, I'm going to go to Internet. I'm so good at this camera thing, ain't I? So I'm going to go to Internet, to the web browser. And it takes a little bit. All right. What? Technical errors. Start a new session, I guess. Okay, and here's the secret sauce. Right there. We're going to ChatGPT. So, and again, I don't want to, so I'm going to go ahead and log in. I actually have an account with ChatGPT, so I'm going to go ahead and log in. And no, I'm not going to give you my login and password. That just would not be that smart of me. Connect the and password. Ta-da! That's fine. Nice Simpson meter. Hey, thank you. I actually have. I like to collect old stuff, and I have. That is a Makanta meter that's hanging on the wall. I do have a Simpson meter. Where did I put it? Now I can't find it. I do have an old Simpson multimeter, analog digital multimeter. I find that very interesting. But I had it apart because I want to rebuild it and get it working because I think it's neat. All right, so now I used ChatGPT to help create this. And I'm going to say there's a couple tips and tricks that I've learned and how to use ChatGPT in order to accomplish these things. So I'm just going to go ahead and show you, not that I'm doing a very good job on camera. Does this let me flip the camera? Hold on a second. I'm going to see if this lets me share. What happens if I hit share? Oh, nice. Never did that before. Sorry, I know this is goofy. I'm a goof. I don't know what to tell you. Oh, snap! I can flip the camera. I'm so special. Okay. Here is what we got. Now, this is down at the end of my conversation, but as you can see over here, I started a category called Raspberry Pi Questions. And if I come up, you can see that this is all the code. So this is kind of how you do things, and this is why I actually really like ChatGPT. So this little section right here, I know it's very hard to read on the screen because, you know, a camera recording a screen, the frequencies misalign and it gets weird. So I'll just read it to you. Would it be possible to write a bare metal program? This is not a bare metal program. I am currently running this over top of the Raspberry Pi OS. There are some things you can do differently. I want to see if I can do this bare metal because it may get a little better performance that way. But yeah. So, you know, I go, hey, would it be possible to write this bare metal program for a NanoPi Neo 4 to perform the streaming function? And it goes, hey, writing a bare metal program, and it gives you a bunch of descriptions, right? And it starts to walk you through, hey, this is how it would work. First, you need a tool chain. Then you need a bootloader. Then you need a hardware initial. And this is all the steps. And then it goes, all right, here's your first bit of code. And then it writes the code for you here, right? So I'm going to go ahead up to the first file. All right, here. This code. We're going to do this live. I'm going to go up here to File. Doop. All right. And, oh, wait, no, that's not what I wanted. I apologize. I'm being a dummy. I'm going to come up here. This button right here takes you right to Command Prompt with an Arduino, right? Did I say Arduino? Sorry, a Raspberry Pi. And I'm going to stick this over here. Stick this window over here. And I'm going to take this window. I'm going to move it over here. All right. Now, this code right here, Nano, and this is what I've learned. All right. So anytime you want to do something, you got to hit sudo. I don't know why. And then you hit Nano, which is a file system in the background. And then you have this whole nomenclature right here. So what I'm going to do is I'm going to hit Git. I'm going to hit copy code, right? It says copied. Now I'm going to come over here and I'm going to paste. All right? And then hit enter. See? Just hit boot, enter, and boom. There's our code. And this here code right here is what that is. So you just hit copy and then paste. Right in there, right? So this code is the executable file. I don't know if I'm naming it correctly, but so this code is the executable file that allows the Raspberry Pi to work seamlessly. So, put the camera down because I feel like some of the people stopped watching because my camera holding skills are magnificent. Not that the imagery is great. I know this camera work is somewhat to be desired. So, you know, for whatever it's worth. So, like I said, these are things I've learned, and I used ChatGPT in order to accomplish this function, and it's actually worked really well. Now, it's not as clear as it's not as easy as saying, "Hey, write a code to do XYZ." It's not quite that simple. You still have to use a bit of imagination and I'm not going to say know-how, but This took 3 to 4. It took 3 days. It took literally a couple nights, a couple hours per night for 3 nights. It took to create and write and apply this code. Um, the reason is because, again, techie dumbass, I don't know how to program. I knew what the hardware could do. I was hopeful of what the hardware could do, and honestly, this was a bit of an investment. This was a bit of an investment that could have not went well, but thankfully it did go well. When you first start out, when you're using ChatGPT to create code for your projects, and this is the biggest thing that I find, like, even if I have to subscribe to this feature, I will, because I find this incredibly helpful for somebody like me. I am at least half decent in creating hardware circuitry. Things like the zero cross, tunable zero cross detector, and drivers and such. I'm at least half decent. I'm not an electronics engineer, so be that as it may. But I am not good at programming. And so many things that we do nowadays, I found this a long time ago, I found this to be true. Back when Arduino first came out, I was like, this is probably going back a good 20 plus years ago. I used to do everything hardware wise. And now we're talking very small projects. But I used to do everything hardware. You're going to need transistors, you're going to need FETs, you're going to need resistors and capacitors and diodes and all the rest of that fun stuff. And then Arduino came out, and it opened up a world, not in the sense that it opened up a world of opportunities for me, but it makes life a little bit easier. And when you get to more advanced projects, it makes life a lot easier. For example, I want to make a driver. That's what this thing's all about. This is a boiler. Well, I'm calling it a boiler. It's the water heater for a coffee maker. I want to make a driver that will use that to maintain a very specific temperature. And in order to do that, that can totally be done via hardware with a simple driver circuit, voltage drop circuit across the thermistor, right? So you would read a thermistor that would be temperature. You tune that thermistor via other resistances. And basically, I'm getting off the rails here, but that can 100% be done via hardware. Even to the point of giving you a digital readout, that can still be done hardware. Not that complicated. However, it's a hell of a lot easier if you have a microcontroller and you can just program it. Then you attach your thermistor to the microcontroller. You attach your driver to the microcontroller. You attach your knob to the microcontroller, and you go typey, and voila. Then not only do you have something that just required some software, some basic C# software writing to accomplish, but you're also able to add extra features such as current reading, safety lockouts, and multiple readouts. Say I can read multiple things on the digital screen with just software. So that's how microcontrollers make our lives easier. And in this case, this I genuinely never, ever would have attempted if it weren't for the ChatGPT. Not because I think the ChatGPT is a very powerful tool, but I'm completely program illiterate. So I literally went into this not knowing if I could make this work. So I did a little bit of research, and then I started going in, and the reason it took 6 hours to accomplish this is because ChatGPT is a very powerful tool, but you also have to use it in a patient way. It's almost like asking a 5-year-old to paint a certain picture for you. You kind of got to point it in the right direction. So I'm just kind of going over First thought, right? Nope. I'm going through the past things so I can show you. There was a good 10, 10 different code attempts, and what happens is you create the idea and you say, chat, can you write the code for I want it to do X, Y, and Z in this fashion? And then it writes the code for you, and oftentimes it'll tell you either how to hook it up, how it recommends to hook it up, or the steps that you need to take, which is incredibly helpful. Although it's incredibly helpful that extra step. You can totally go like they could hold it back a little bit and it would give you the code, and then you could say, how do I implement this code, and then it will give you the instructions to implement it. um, you can get down to finite measures like that, but one of the things you will come up with uh, is debugging. It is very helpful for debugging. So pretty often, unless you're like a master programmer, your first program is not going to work right. And you're going to be scratching your head like, oh, bothersome. Now I need to figure out why this code isn't working right. And what you can actually do that ChatGPT makes very handy. All right, I'll show you. Here is a snippet of code. Oh, I can flip the camera around. Sorry. So here's a snippet of code that I pasted, right? Sorry. So this is a known incorrect RGB file. So this is an error message that I received after running this code, right? So I ran this code and then went, hey, here's the error message. And then it says, oh, your error encountered indicates that OpenCV is unable to capture the frame from the camera, right? Ensure the camera works with OpenCV. Then it gives you this code. Then it says, all right, do this and do that and do this and do that. So as long as you're patient, and as long as you're patient and you walk through the steps with it, like baby steps, it'll get you there. It has so far helped me program about 4 different projects between Arduino drivers and now the Raspberry Pi. And this is by far the most complicated programming project I've ever worked on, because there's no oh, obviously it's the piece of hardware, but all I had to do was just, put it together. There was no circuitry, there was no soldering involved, there was none of that. Just put the hardware together and then program it, and shit, it works. That's the cool part about it. So, you know what I'll do now is I'm going to go ahead and I'm going to power this thing down, and I'm going to unplug all of the other things that it doesn't need, so that it's just acting like a stream device. Shut down. And that's another thing that's really nice about the Pi 5 is that power button. You can turn it on, you can turn it off via the power button. You don't have to have a screen attached to it to be able to turn it off. So that's kind of nice. All right, so that's needed. The Ethernet is not needed. The keyboard is not needed. The mouse is not needed. All right, let me show you. Nobody wants to see me that close. Okay, this is my Raspberry Pi. We got power, we got HDMI, and the USB in. All right. Now I'm going to go ahead and hit the power button. This is awkward. All right. It's going to take a little bit of time. That turns green. You can see we got fan spin. This heatsink actually gets a little warm. Not really ever that particularly hot. All right. That boots up. It's going to go to desktop and then camera. Boom. Camera. And now we're streaming. You can actually see a little bit of the flicker. It's almost like the motion blur is off, so it seems a little odd. But, yeah. That's it. And, so that is the successful project. Sorry, I'm putting the tripod out. I'm pretty stoked with this, because this is going to save me quite a few $100s. Here's the entire point. The Blackmagic ATEM Mini, or any of the ATEMs, and there are other companies that make them, but Blackmagic has a really solid reputation. They're not that expensive, right? And they're streaming hardware. So if I want to rebuild this live stream so that, you know, we can have multiple camera views and actually some nice optics, that's the device that I'm going for, is the ATEM Mini. The ATEM Mini pulls in HDMI ports. Well, I have one camera that's worth a hoot that's HDMI out. It has a clean HDMI out. It's the Canon M6 II Mark II. It does have a clean HDMI out, so that camera would work, but that's the only one I got. Other than that, I've got USB cameras, and I just paid for these bloody things. So I've got 3... Did I say HDMI? USB. I got 3 Elgato USB cameras. The Facecam Pro and 2 Facecams. Not only that, the little mini USB cameras fit into places that HDMI, like full HDMI cameras, just really don't. They're less convenient. So, now I can spend significantly less money. Now that I've got this working, I can spend significantly less money, continue to use the USB cameras I have, and still use a very solid, commercially viable piece of hardware to accomplish the same streaming service, a better streaming service. So, I'm really happy with that. Again, I'm going to put this project on the Patreon. It's, if you want to look into the Patreon, I gotta refine the Patreon a little bit. But yeah, if you want to find this project, if you want the code, I'm gonna pay. I can't talk. Must need more liquor. I'm going to put the code into a project file on Patreon, and or GitHub or something like that. I don't know how that. I really don't know how that works, but that's what I'm gonna do. So that if you have USB cameras and you want to stream them to an HDMI device, like a capture card, then Raspberry Pi 5 or 4 maybe. So Raspberry Pi and a little bit of coding, and there you go. I don't know what else to say. All right. What's next? Right? What's next? I am going to continue working on this project. I'm gonna now that it's successful and I know it works, I'm going to put it on the second shelf. My next idea is to create a bare metal program, or close to bare metal. It turns out a bare metal program can be a lot more complicated, but I'm feeling pretty good about what we've accomplished here, so I may try it. So that project, my next couple steps is I'm going to try doing bare metal programming for that. But I may not, because I have other things that I'm working on, and the target I have to get back on to the engine, the generator. I'm going to call it a generator instead of an engine. The catalyst turbine generator. So I got to get back on that. And if you want to know where we are on that, let me refresh my memory. So, the turbine engine. Oh, all right. I'm working on the driver mechanisms to build the boiler. So this thing I'm turning this thing into a chemistry set. You know, exciting stuff happens when you say, "Hey, I got this big stainless steel gadget with a big heat thing, and we're making a chemistry set." Woo, fun stuff. But no, seriously, I'm going to start purifying hydrogen peroxide, and what I'm working on right now on the bench is the driver for that. So my very next step in the next live stream, the thing I'm going to be doing is building and programming, building the mechanism to program and programming with ChatGPT's help. These little chips, they're called 80 Tiny 85 chips. These things right here. So it's this. This is the socket. That's the chip. So I'm going to program these. Believe it or not, these are programmable. It's just an 8-pin chip, but it's programmable. So I'm going to program those for the driver circuit, and then I'm going to start building the actual Triac driver. The Triac driver, we've already got as far as knowing that it works, knowing how we need to hook it up to work, and I think all I need to fine-tune on that driver is a snubber circuit. I want to create a snubber circuit to balance, not balance, to tune the output, I guess. But yeah, that's that. It's a little complicated for me, anyways, at this point in the game. Right now, all I have is the the breadboard. But we did, and this was on a live stream. We did this on a live stream, and you know, this works. This is the Triac driver right here. We got an opto isolator right there, and then this is a Arduino Nano to drive it with a potentiometer to turn the speed up and down. So I need to refine the driver. What's up, Goat? I see question marks. Trying to explain what we're doing, but yeah. So I need to refine that driver. So that's going to be the next thing we work on the channel on the next live stream. Is oh, you know what? I could totally make a video about the Raspberry Pi thing. How would I do that? I can't edit videos. I'll figure it out one way or another. So yeah, the next live stream is going to be building the mechanism. Check this out. This is one thing. This is one thing that I think would be interesting, right? I'm a fan of the Arduino, and this is what's called an Arduino Uno Mini, and it's basically a mini version. Where's my Uno? Here it is. My bench is a mess. So this is a normal Uno. Arduino Uno. This is the Mini. Right? It's approximately the same capability. I'm not sure if the pinout is the same, but it's approximately the same capability. Actually, the Mini might even be a little bit faster. But the Mini also has a USB-C connector, which I like that much better than the micro or the mini connector on the Uno. I want to use this to program the 80 Tiny chips. Just because. It's like, what do I do with this thing? Oh, I don't know. For the longest time, I just kept it in the boxes like, hey, check it out. This is cute and neat, and it's a collector's edition, whatever. But they still sell them, so it's like, they're still making them, so it's not very collectible at that point. I mean, you can collect it if you want, but it's not going to go up in value, that's for sure. So I'm like, I want to use it. And I just think this is the perfect opportunity to make a tiny little 80 Tiny programmer. It'll take a custom PCB. It's the biggest deal. Because these pinouts are much smaller, so I can't use a standard PCB. But, you know, we'll get there. So I think that would be fun. So, yeah. Next stream, that's what we're going to work on. I don't have a whole lot else going on. I just really wanted to show you what we accomplished. Like, this is a big deal for me. And I hope this is probably a fairly narrow case out there for people that have USB cameras, but I hope that this is actually turns out to be useful out in the world, the Internet of Things, because it will be definitely useful for me. So, thank you very much, everybody, for watching. I really appreciate it. I'm going to go ahead and start closing down the stream from here. Yeah, everything else that I have going on is going to take some more preparation. So, and I didn't want this stream to be excessively long and doing random things. So, hopefully you guys learned something. Hopefully you got a little bit of entertainment. And, Velez. I'm sorry, dude. I don't want to butcher your name. Goodbye, 28. Yeah, so hopefully you guys learned something, found it interesting again. If you go to the Renaissance Builder on Patreon, I'm going to put this project on there. So anybody that wants it has access to, anybody that can use this thing can have access to that. Literally, all they'd have to do is just buy their equipment, go download the program, and make their own. Really easy. Thank you very much, everybody. Have a good one. Till next time. Take care.